Hello, hello. Good afternoon. This is Junichiro, and I would like to start a live stream for this week. I didn't do the last week, so sorry for that. Okay, so this is Junichiro Horikawa, and this is the weekly live stream for Houdini tutorial, which is called as Houdini Algorithmic Live. And I'm doing this per weekly to show some process for algorithmic designs using Houdini. And the topic for this week is to create a simulation for so-called Canadian Smocking, which is a technique of stitching on a cloth or fabric, which looks like these. So based on these patterns, you just stitch the clothes to create to be able to create such interesting textures or patterns. Okay, so I'm going to try to simulate this pattern using Houdini together with the Vellum system. Trying to use the pattern shown here to be able to create a similar pattern like these to see if it's gonna work. Okay. Now I did some trials using Houdini, Vellum, and it wasn't that simple to do. It looks pretty simple from the pattern. It seems like you just need to set some springs between some of the places on the fabric, but it wasn't just that, because you do need to also set the rules, which part's gonna be a mountain folding and which part's gonna be a valley folding and so on. So you do need to set some rules for that, constraints for that, in order to achieve a clean pattern like these. So I think that's gonna be some little tips you might find interesting or useful in some cases. So this is one of the example I created. The pattern, it looks like these, and using a base plane like these and having a line pattern like these as a stitching pattern, you'll be able to have a final result, something like this as a simulation. So yeah, I thought it looks pretty interesting. Didn't really expect this pattern to come up from the line pattern that I drew, so looks pretty interesting. And the method that I'm gonna show you could also work on three-dimensional geometry, so might be useful for some cases as well. Okay, so this is just an experiment and nothing production ready, but if you found it interesting, that will be awesome. All right, so let's try to create this from scratch as always. Okay. So let me also know if you have any questions. Okay, so see. Okay, so there's one question. I would like to see how to inflate this type of effect. So yeah, that's the key point. I wasn't able to inflate this. So I am using a little fake trick in between to make it look like it's inflating, but you're gonna know what I mean by that. Okay, so first thing first, the basic setup that I need to create is to create a vellum cloth together with some stitching constraints, these lines, as a spring. So let's create that first, which is gonna be pretty simple to do. First thing first, I am going to create one of the pattern for the stitching. Let's just choose the simple one. Let's see. So I'm gonna try the one that I already tried. Something like this one, which looks cool. So I'm gonna try to create this pattern first on a grid. So it's 90 degree rotated, but it looks like you have two diagonal curve and opposite side on the next row. And you have same patterns on the same column with one grid skipping. So to make it simple to create these kind of pattern, I'm just going to use a curve polygon to create a pattern by myself, and later I'm just going to place it in a row and column using a grid, placing as a grid. So I'm going to use the curve polygon and to place the grid as a guide to snap on. And I'm also, before doing that, maybe I would like to make one size of the grid to be equal to 1, so that will be easy to know what's the size of the pattern. So to do that, I think I need to make this rows and columns 11 and 11, so that I'll have 10 columns and 10 rows for this grid. Okay, so using this grid as a guide, I am going to draw some pattern as a polygon line. So one curve like this, one line like this, one line like this, and one line like this. Okay, so this will be one element which is going to be continuously placed on the column direction and row direction. Okay, so you can either use attribute wrangle, or maybe I will just gonna use for each number 2 for each numbers to place it on the grid. Okay, so whilst you're going along, can you pause a second to explain functions you use a bit more? I sometimes have issues knowing how to call functions on various nodes, using for each node and detail attributes to use functions in other nodes. How to call functions in various nodes. It's using the for each node and detail attribute use. Okay, yeah, sure. Okay, for now I am using for each numbers because I want to place these base curve on a column direction in X direction and Y direction separately. So I need 2 for each loop nested like this. Okay, like that. So this could be for the X direction, this for each could be for the next direction, X direction, this for each node could be for the Y direction. Now I could either use transform or point wrangle. Maybe I'm gonna use point wrangle because I can set my own parameters easily compared to transform node, because if I use transform node I just have to write all the expression in one input in channel here, so it's gonna be a bit cumbersome. So I'm gonna use point wrangle to try to move these element on the X direction and Y direction on each iteration for the first loop and the second loop. And for the first loop, I'm gonna connect this for each count node, which has an information on a detail rank, on a detail attribute, which is an information of what's the current iteration is for this loop, so that I can use this to use it as a step on the X direction. So I'm gonna try to get that info from a detail from the second input. Now this goes from 0, ends at 9 because I am currently using 10 iterations for this loop. So X on X direction, I might need to move iteration multiplied by some amount of movement, which is an integer because the length of this base element is the multiplication of 1. So I'll just call this X scale. Okay, now I can now move this point X with the X value that I've just created, add it to the current X coordinate to see how it's gonna work. Now I do need to promote one parameter, this one that I've just created, in order to move the pattern. So for this pattern you need 1, 2, 3, 4 grid to move to the right direction with one space in between the element. So you type 4. But based on different patterns, for example, if you use different patterns like these one, you might need this maybe 4 or 5. This could be one element and could be moving, probably this is 4 as well. So based on the pattern you have different direction to move on X direction and Y direction. So making these parametric, it makes sense. Okay, so now you have 10 elements on X direction. Let's do the same for the Y. So for the Y, you can use this one, the detail attribute from the first loop, and you can use that iteration as a Y value. So let's call the first one iteration X, the second one iteration Y, connected to the third input, iteration Y multiplied by Y scale. Right, then this way, this time I am using XZ plane, so what I want to move is the Z coordinate with this Y value. Now increase these to see what's the best pattern. Okay, so this is 3. The step that I need to move on Y direction is 3, I think. So what was the pattern? Yeah. So it looks like these 90-degree rotated, but it looks pretty much the same. So that's good. Now you can control how much pattern you need by changing these for loop numbers. Okay, so let's connect all those parameters that I've just set into one place so that I can control it easily later. I'm gonna create a null node, open up the edit interface, uncheck for a bit parameters from outside the subnet so that I can drag and drop the parameters, such as this iteration X iteration y, name this x repeat, this is y repeat, and these one, this is x offset, and y offset. Alright, so I have 4 parameters to control, to create a grid of base elements that I've created with this curve node. Now I'm just gonna keep this grid as a guide because I want to try different pattern later. Okay, so that's that for the pattern grid. Let me save this to the today's folder. Okay, now I have a question from Valarts. Why nested for each node? This is the second time I've noticed someone doing so. Provide that link for us to as well if able to allow. I think first of all, the YouTube channel, YouTube comment doesn't allow link to be pasted, I think. So every link pasted on a chat is going to be removed automatically for some reasons, which I don't know why. So I don't think I can provide a link here directly. And the reason why I'm using nested node is because well, it's easy to control because for the first loop you want to copy this element to x direction with some numbers with using one loop. So if you just have one loop, then you can only go to one direction. Then after creating one loop, you have one row like this, and after having one row, you need another loop to go to the other direction to create a grid. So the y direction is going to be the second loop. You need, if you have one row like this created with one grid, one loop, you need another full loop to go to the y direction. It's like create a matrix. It's in this case you have 5 on the row, 5 on the column, so you have 5 by 5, 25 patterns. In order to have 25 elements on a 2D grid using nested loop like this makes sense. I mean, yeah, you could still use just one loop to create a grid like this, but you need to know how many numbers you're gonna need in order to create a 5 by 5 grid. In this case, you need 25 patterns on 5 rows and 5 columns, so you need to have that information in one loop. In that case, you need to calculate x and y direction just from one iteration value, which is going from 0 to 24, which is possible but cumbersome. If you could use nested loop, then why not use it? Okay, I have a question about your book, Automatic Layer Generation. Bought that some years ago. If you did it today, would you do things different? Do you plan to do something in the architectural field in future? Yeah, I think I will try different approach for sure. Because AI technology is being updated so fast these days. I guess there are more useful tools these days, which could be used for flow generation. So yeah, I would, as an experiment, I would just try something else for sure. And if I would do any architectural stuff in the future, yes, for sure, because I'm still in an architectural field as a job. I am working on architectural field somehow, so pretty sure I will do something like that in the future. Okay. What was I? So now that I have these curve, which is going to be used as a spring to stitch points together on a cloth, let's just create a base cloth. So I'm just going to first create a bounding plane covering all these curves and use it as a base plane. So I'm gonna choose rectangle and have some margin or padding on X and Y. Maybe I don't need these. Okay. Yeah, something like that. So I have one grid of offset, which looks good, which looks decent. So let's go with this. Now, next thing I like to do is in order to create some simulations, I need to have tons of triangles to create a smooth surface for sure. So let's do some remeshing. Now, it might be better if you can control the resolutions of this mesh, so let's have that as a parameter as well. I'm going to drag and drop this target size. Okay. Now, let's start with 0.2, and now the important thing now is that I need to make sure that there is a vertex on the corresponding place where I have placed these spring curve. So if I look at the mesh, right now there are no corresponding vertex on a mesh, which is equal to the position of endpoints of these springs. So first thing I need to do is to move the closest vertex, which is close to this end point of the spring, which could be something like this one, to move it right here, which will change the size of the triangle somewhere around here. So I might also need to remesh again to make every triangle's area to become somehow equal for a clean simulation, for clean result. So in this case, maybe something like this one. Now this one comes to this position. All right, so let's try to do that. So I only need one closest point to move to the endpoint. So in order to do that, let's think what's the best way to do. I think I'll just use attribute wrangle, connect it to the mesh and change this to detail. And I'm gonna try to make a loop for each guided spring curve, which I'm gonna connect it to a second input. And for each curve, I'm gonna find out the endpoint for each spring, and for each endpoint, I'm gonna look for the closest point on a mesh, and for that point on a mesh, I'm gonna try to move that to the certain spring endpoint. Okay, so let's do that. First thing first, since the spring curve is being connected to the second, I'm gonna make a for loop to loop through all the springs coming from second input. So n primitives is the number of primitive coming from second input. This means second input. So if I have 120 curves, I am having 120 loops. Okay. Now for each primitive, I'm going to get the end point from each line using prim points on index I, which is this one. I is from 0 to 119. Now, I know that this is just a line which has only 1 and 2 points on each primitive, so I can just say pt1 is the first point, pt2 is the second point. Then I could get the actual position from that point number. Okay, so this could be the starting point of the spring. The path 2 could be the end point of the spring. Now if now that I have 2 points, I could use that to search for the closest point on a mesh. Okay, so I could use a function like new point on the first input using position 1. Same for the end point, np2 near point 0 position 2. Okay, now this point number should indicate the closest point number on a mesh. So for this starting point, the closest point on a mesh should be somewhere like this one, which in this case the point number is, it's a bit hard to see, 3506. Okay, so that's the number I should have got with this new point. Same for the end point. Now using this point, let's see if I have got the right numbers first to test. I'm going to set the color to test out if I got the right value. Just try to make it red for the endpoint. I'm gonna try to make it blue. See if it's working. Okay, so overlaying the curve, I think it is getting, so the endpoint is right here and the mesh, the red point is somewhere around here, so pretty close. Yeah, it seems correct. So now I think I have picked the right point, the closest point on endpoint. I just need to move this point, which is equal to the endpoint of this spring. So I could just do that by set point attrib 0 p to the point position from the spring. Same for the spring 2, the point 2, like that. Okay, so you could see that the point has been moved to where the spring exists, and you also notice that there are some distortion on these triangles. This is not so obvious, but sometimes it could be really obvious. Like this one, you have really tight angle. So in some case, this might be problematic, especially if you have a low res mesh like this one. It's pretty obvious that the triangle shape is a bit weird. So in order to fix this, one possibility, one idea could be to use some smooth node to smooth out the surface just by fixing those endpoint of the spring as a constraint. So I'm gonna do that. I'm gonna try to do that by setting the weight attribute to these fixed point, or the spring point. Set point attribute as 0, so that because I don't want to move that point. And for those points that I want to move, I want to set the weight as 1. So before connecting this attribute wrangle, I could just have another attribute create node to create a float attribute called weight, set the value as 1. So the default value for each point weight value is equal to 1, but then having this detail attribute detail wrangle, I could set some of the points weight to be equal to 0, and I'm not seeing 0 value here. Okay, so some of the points being set to 0, which is where the point is equal to the position of the spring endpoint. Okay, now that I have set the weight, I could now use a node like attribute blur. Oops. And use the weight attribute as weight, which will fix, which doesn't affect the point where the attribute, the weight attribute is equal to 0. So those points where the weight attribute is equal to 0, it's not going to move, but all the other points is gonna move based on this weight, as you can see like this. And because I'm using blur node, this is going to try to make the area of the triangle for all the areas to be equal to equal, or as an average, to make it as a smooth surface. So this is one idea, trying to fix the constraint points and just let all the other points to move, which looks a bit brute force. If you don't want to change the original point position, this might not be a good idea, but in this case I'm just using a remesh node, so it should be fine. So let's just do this till 50 or something. Now I should be able to have rather clean mesh, even though I have constrained some of the points, fixed some of the points position. Okay, let's make this back to 0.2 as a target size. Now that I have two information. One is the point for the spring, and which could be the endpoint and which could be the starting point. It's time to think how I could create a actual constraint for the vellum. So let's try to think what kind of constraints that I need to set here. So first, obviously, I need to use cloth for sure. Okay, using cloth node, you'll be able to create two types of constraint altogether. One is the stretch constraint, one is the bend constraint. And stretch constraint creates a spring for each edges, tries to keep this current length. Okay. Another one, the bending will create a bending force between two triangle pairs. A pair of two triangles. Try to keep the angle between two triangles to be equal to the current angle, in this case equal to 0. So that's good, but the additional constraints you want here is some spring which connects this point and this point, and make the length become 0 during the simulation, so that you'll be able to simulate the stitching effect. So if you look at another Vellum constraints and see if there's any good constraints that I could use here. One of the stuff that I could use is maybe glue or stitch points or distance along edges. So I could use one of the constraints in order to create a stitching effect spring. Now H1 has, well, H1 just creates the same stretch spring type constraint, so anything is fine. You just need to, the process of making the constraints is just different, so you can just choose whichever you want. And each one has, you do need to have some steps to follow for each constraint. So in the example that I showed previously, I used stitch points. I also tried glue. I haven't tried distance along edges, so maybe I could use this one. I could use this to try out, maybe. Yeah, this could be useful. But in order to use this one, you need to add additional line before creating a Vellum constraints. So that might be a little hard to control, but let's see. Okay, let's try to use distance along edges, and I'll show you what's the best way to create that constraints. Now, since I already have these curves, why not just use these as a constraint base? So what I would do, first I am going to make a group for this plane. I'm gonna call this as base primitive group, and for the spring I'm gonna call this as spring. Okay, and merge it together so that I could use both. I could see both geometry in one node, one for the spring, one for the base. Now important thing here is that I need to fuse the point because currently the primitives being separated using unique points to create this spring and the base mesh. So I need to merge or weld the point right here on the end point of the spring, this one and this one, so that when the spring moves, the mesh also moves. So this is important. Now connect this to a closed Vellum constraint and just create the close only to where the group is equal to base. Now this will ignore the spring geometry. Now for the second Vellum constraint, I'm gonna choose the distance along edge and choose spring. This will create the constraints on these spring curve. Okay. Now, important thing here is that I need to change the group name so that I can control this separately. So, how do I call this? Stitch. All right. Let's call this stitch. And you can also separately control the stiffness. I'll try to change this later, but for now, keep it as a default. Okay, so now that I have 2 constraints, or in total 3 constraints, distance for the clothes, bending for the cloth, and distance for the stretch. Now having these 3 might be enough to do the basic simulations for this Canadian smocking. So let's try what will happen with that. So Vellum solver, and I'm going to disable gravity for now. Okay, just multiply by 0 so that the gravity is equal to 0. And anything else, I'll just keep it as a default value. Now, what I want to do here is to set the rest length of the stitching group, stitching constraints, to be equal to 0, so that I'll be able to simulate the stitching effect like this. So this edge will become shorter, and the distance of this edge will become shorter and shorter to have a stitching effect, something like these. Okay, and let's see if I could create a similar pattern like this one just by shortening these edge. So go inside a Vellum solver. I could use Vellum constraints, properties, filter it with the group called stitch, and change the rest length scale. This is using the rest length original attribute. And the actual rest length is going to be the multiplication of rest length original by this value. So if it's equal to 1, you get the original length. If you set it to 0, you get 0 length. If you make it 0.5, then you get the half size of the original length. So I want to try to change this gradually based on the time. So using fit function with the frame, starting from 1 to, let's say, 50. I want to change this to from 1 to 0. See what happens. Okay. So let's see. If I play this, now obviously seems I need a little bit of bending stiffness because this is a bit too wrinkly. It's a bit too soft as a cloth. So I need a bit more stiffness for the bending to have a bit more, I don't know, hard rubber-like bend. So make it, I don't know what's the best value, but 0.1 maybe. Let's see. Okay, starting to have some pattern, but doesn't really look like the pattern we're looking for. Okay, let's try to make the bending a bit more harder, like 100. Okay, still see. First thing first, I do see some like I am seeing that the pattern, the object is being flying around over the space because of those forces. So it's a bit hard to see the pattern here. So let's try to add gravity now. with some ground. See if it's gonna change anything. But in the future, I don't want to use the gravity because I want to also make this on a 3D pattern. So in those cases, gravity won't help. Okay, not good, still not good. Let's make the gravity a bit more stronger, like 10 times bigger. Okay, now starting to have some pattern here. But as you can see, the pattern you see here is not really close to what we would like to see as the final pattern here. Not at all. Maybe the gravity is a bit too high. Okay. But as you can see, not so good. Not so good. The first problem that I could notice is that in this case, in this pattern, when I have these stitches, you always want to have the pattern as a mountain-like folding, meaning you always want situations like maybe this one. So if this is the starting point and this is the end point of the string, you always want to have a mountain shape like this going upward. But just setting the spring will sometimes create a valley-like folding, something like these one. Okay. Right, like these ones. So that's pretty problematic. And that's what I would want to fix. And also one more things that I want to fix is this gravity issue in order to prevent flying this away. So let's start from that. Let's replace the gravity with some other force so that it doesn't go far away from the original plane. Let's try to keep the position of the original plane as much as possible. So I am going to introduce another force here, which is called attractor force. So using the base grid as a guide, and I want to create some glue-like force to each of the point on a mesh, which tries to go back to the original position with really small force, so that it doesn't go away when external force has been created, like stitching effect. So let's create some really weak attractor force to this one. So how would I do that? In order to create a attractor points, there are no such name called attractor and vellum constraints, so you need to just create your custom ones by yourself. So you gotta choose the template first, which one will be the best template to create an attractor one. Now I think glue will do the job, so I'm gonna choose this glue attractor, glue force constraints as an attractor. And where should I place that? Now maybe after using the fuse node, this is the finalized point positions. So I could first delete all the primitives from here, which keeps only the points like that. I just set the pattern to asterisk and check keep points so that I only have points from this geometry. And this is going to be the the guide points, which all the points on a mesh will try to adhere like a glue. And this points should not move at all as a base. Mesh could move along the Vellum simulations, but along the simulations these points should not move, but stay as they are right now to be the points where each of the points on the mesh which tries to move with the simulations tries to go back. So I need to create some springs in between this point and this point as a constraint. So to do that, I need to set another group here. The left side group, I need to make a point-based group. Let's call this pull source, or maybe attractor source and right hand side points, I'm going to set it as attractor target. Alright. Okay, having these 2 points set, I'm going to merge them together and connect it to the Vellum cloth, which doesn't really affect the later constraints creation because these Vellum node only looking for the primitive just ignores the point. So having additional attractor target points, it's not really a problem for these one. But additional constraint that I want to have here will look for this attractor target, which I'm going to set it as glue as a base. Okay, and looking for the points with the group called attractor source. This is going to be the base, and also you need to set the target, and that target is going to be the attractor target. Now using the glue, you can search for the closest point from the source to the target, and you can make, since the point position is on exactly the same position, you can set the search distance to really small, and you can only look for the one point for each source. And that will create a constraint line or spring for each point, which connects the mesh with the original point position. Which currently the length is equal to 0, so you can only see the points, but this is actually a primitive. This is actually a line which has 2 points. Okay, so in the end you can use this to pull the mesh to the original position. If the strength is really big, then the mesh won't move. If the stiffness is small enough, you can use it as some kind of a weak attractor force. So make the stiffness pretty low, like 1 or 0.1, to make sure this is not too strong. Okay, now another setup you need to do for these points is to set up the collision settings for these points. So these points are going to fixed on the grid, so these points should not have any collision information. The mesh shouldn't be collided with those fixed points. So you need to set some attributes to these points so that it's not going to be used as a collision. So for that, you need to set some special attributes to indicate that these points are not going to be used for the simulations in terms of collision. So you can search for specific attributes for Vellum on a help called Vellum Attributes, and if you search for the collision, there is an integer attribute called disable self and disable external, which indicates that if this value is equal to 1, then those points are going to be ignored from the collision. Default value is equal to 0, so that all points is going to be used for the collisions, but if it's equal to 1, then collision is going to be disabled. So I'm going to set this collision attributes for these base points, the fixed points, to be equal to 1. I also don't want to move these points. I want to fix this point to the original position, not being affected by any forces. So I'm also going to set the mass to 0, so that it's not gonna move because it doesn't have a weight. For the left hand side, you need to do the opposite, because these meshes need to move and need to have a collision. So set this to 0 and mass to 1. Now the mass information is going to be overridden with the cloth constraints later, so it doesn't really matter if you have this or not, but anyway. Okay, so having those information, I think you are ready to use the attractor. So let's try simulating this again without having a gravity and ground, and see if it's gonna still fly out or not. Play it. Play it. Okay, now the points where you have the spring is moving, but those points which you have applied the attractor is not really moving. Seems like the attractor force is a bit too strong here, and somehow it's a bit freezed. Okay, you can see that the spring is moving, but the other point is not really moving, so maybe I have some problem here. Let's see why. This could be one of the reasons. Maybe I don't need the compression stiffness here. And what else? Let's try. Nope, still not. Okay, I want to make sure if this is causing the problem, so disabling the glue, see what happens. Okay, so it is moving. So that's good. So maybe the glue force is a bit too strong here. If I make this a bit weaker, like 0.0001, see what happens. Okay, now I seem to have missing the stretch force on triangle here somehow. These triangle mesh is causing some real problem. So maybe I'm doing something wrong here. Seems like I'm having... Okay, wait, okay, this is the problem. I need to change the group name to something else because it's being used with the cloth. So let's change this to tractor. All right. Again, let's see what happens. All right. So it's now in this case, the attractor force is not too strong, so it's just going to the center. Let's try with 0.1. So this is a bit strong. So you can see that compared to the last one, it's not going too far from the original position. It's getting better. So in terms of the attractor, I think this is fine. Yep. Okay, let's also delete the attractor points on the end so that I don't have to see those points in the end. Okay. So in terms of the attractor, that's fine, but I still have some problems with these folding direction or inflating direction. In this case, you want to have the inflating upward, not downward. This is fine, but this is not okay. Same for this one. These spring is acting okay, inflating on top direction, but this one is not, which is causing unstable pattern. Doesn't really look like this one. So here's the trick. In order to control the inflation direction, I tried a lot of stuff, like adding additional constraints. I tried adding all sorts of constraints, like up the constraints to the normal direction for the valley folding stuff, or adding additional bending to those in between those springs, which didn't really work as well. And what really worked most is to set the initial state to make it look like it's already half the inflation and on initial state, meaning if there is going to be an inflation between these springs, set the initial state to have the mountain already, which as an initial state have a invalid lengths, edge lengths for the cloth. But what I'm trying here is that set the initial state as a mountain, which does give you an invalid length, but over time make the edge of the mountain shortened back to the original plane to have optimized geometry. So in the end, you do have the invalid edge lengths by shortening the edge to the original lengths, but the initial state just create the mountain between the springs, which did work and did create the inflation pattern like these one. So that's what I would like to try here. Okay, which is kind of a fake in terms of the actual simulations, but the actual the things that I want here is the final result, not the, well, pretty much the process as well, but the final result is most important here for me. So that's the approach that I took. Okay, so let's try to use that approach to solve this problem. Now, before doing that, I do see some problems that I like for the springs there are some spaces in between spring, even though I have set the rest length equal to 0. That might be coming from the close constraints with these thickness here. This might be doing something wrong here, and also all the other constraints also have them thickness. So for those which has the thickness, make it really small so that I have smaller space in between the surface collision. I mean, for the distance as well. Maybe this one doesn't have any thickness here. For the cloth, I'm gonna set this to 0.01. See what happens. Another reason could be the stiffness of the spring, which currently I'm not sure what was the value. Well, it's pretty high enough, so maybe the another thing I could control is the amount of stiffness for the bending. Maybe the bending stiffness is a bit too high here. Okay, anyway, that's a minor thing. Yep. So as you can see, not so clean at all. Right. So to fix this, as I said, I'm going to create an initial state so that to make a guide as which direction the inflation should go. To do that, you need to have a spring information for sure, and a mesh which you want to modify. And I'm just going to create a mountain-like shape here based on where the spring is closed nearby. And then use it as initial state, and during the simulations I want to make the edge lengths back to the original lengths so that the final result should have the valid lengths, valid size, valid lengths for each edges. So to do that, where should I do that? I should do that before creating constraints, I think. So somewhere around here. And I should also not change these attractor points. So maybe somewhere around here, I guess. Yeah, somewhere around here. Okay, so I could use a point wrangle for the mesh, and as a guide I need a spring, so let's connect that to a second input, which I already have the spring inside this node, so maybe I could also use that as well. Yeah, maybe. And yeah, maybe I could just use that. What I would do is to calculate the distance between each point and to the spring. So, and I also want to use the UV of the curve, where of the projected point on a curve, and use that UV value to indicate the mountain shape. So first thing first, you need a primitive information, UV information, and you can use XYZ distance function And since the spring is in 0 and the primitive group you want to search for is the spring, and you're going to search with the original point position on each mesh, on each position on the mesh, and as an output you need primitive and UV. Okay, now first you need to kind of limit the search area for this distance. If it's close enough, maybe you can create it as a mountain shape. If it's far, then maybe you don't want to use that. So let's create a threshold value which could be equal to the remeshing resolution. So I can copy this target size here as a threshold. Right. So creating a if condition, if the current distance is less than the threshold, then create a mountain. So let's check how it looks like. So it is picking up the points where it's close to the spring shape, like this. So what I want to do here is to create a mountain shape like this, the clean mountain shape, not like these walls, but more like a round mountain. So to do that, you could use this UV. The starting point of the curve will have u equal to 0, and the end point of the curve you have u equal to 1. So using that information, you could kind of constrain the height of this mountain right here. So to do that, first get u value, which is from x coordinate of the uv, and u is always in between 0 to 1. So multiply that with pi, and then use it with trigonometry function like sine, which will create a value in between 0 to 1, but as a mountain shape. So if I just use this h instead, this will create something a bit more understandable value like this. And probably you could also use this d value as well to control the the height. So if the d is close to 0, you want to have a higher value. If it's close to the threshold, then you want to have lower value. So you can multiply this by fit d, which is in between 0 to threshold, and if it's equal to 0, make it 1. If it's close to threshold, make it 0. Okay, something like that. Okay. And this, well, but seems like this is a bit too pointy, so maybe I actually don't really need these. I might not need these constraints. Maybe if I can set the constraints, maybe set the threshold to a wide area, like 2 times more. Maybe that's better. Yeah. Okay, let's go with this. So what I'm making here is the base initial condition, so that those those place where I'm setting the spring should always have a mountain-like spring. I do need to fix this later, because as you can see, the edge length is being skewed a lot, distorted a lot, so I need to fix that distortion during the simulations, but as an initial state this works fine. Okay, maybe the height might be too high or might be too low, but don't know if this is good enough, so let's make it parameterized so that you can control the base height. Okay, also maybe this could be too pointy, or this could be this might be still okay, so let's also have additional value like attribute blur to smooth out the height. Now what's important here is that I still don't want to move those spring points, so use the weight here as well so that these points never moves, only the mountain will change the shape. Okay, so if I have these smooths, even if I have really high mountain, you could still have smoother result by having this blur iterations, making all the other positions become a bit higher. Now, not sure if it's gonna go good or not with this condition, but let's see. Okay, so let's try with these and see what happens. Now, and the important here is that this should go to the attractor source, okay, which will create maybe this shouldn't go here, because in order to create an attractor attribute or attractor constraints, the position needs to be on the same point, so maybe I shouldn't do that here, but maybe I should do this between these two constraints. Or maybe after creating the close, because in the end you need to make the rest lengths back to the original conditions, which is this one. The rest lengths equal to the current edge lengths. So if you look at the second output on a primitive, you have these rest lengths, which is the edge, the length of the edge, and these edge lengths should be the final result for the pattern to make it look real. Okay. Well, this distance, this is for the spring, so maybe I could just do all those moving parts. It's a bit hard. Let's see, where should I do that? Where should I do that? I could, well, any place is fine, but maybe what if I put it here? Now this will create a close constraints based on this initial state, where the edge length is totally wrong for sure, and this is also moving. This is moving the attractor points as well, seems like. So that's not what I want. I just want to move the attractor source. Okay, now looking at the constraints here, you are getting these wait a minute, Okay. I also need to change the point position of the constraints here based on this points. The point number is the same, so just need to make it synchronized and make the point position of the constraints and the original geometry synchronized as the so that it's gonna work properly. Like that. Okay, so now you are visualizing the attractor constraints like this. It's cool. Okay, now you have these edges here, but what I actually need is not what I actually need as a target on the end result is not this length. This rest length is the initial coming from the initial conditions, but I need to change these rest lengths to the original rest lengths in the end. So you need to have the original rest lengths somehow. And where can I get that? Well, I could get that by using the convert line to this original mesh. And I think the primitive number of this converted line and the maybe not. Maybe the easiest way is to just use the dummy cloth constraints created for the mesh, which it's not affected by the initial wave condition. And use this constraints as a guide, as a goal. Okay, so this is the current rest length, this is the goal rest length, and for the current rest length, in the end you want to go to this. You want to set the rest length of this constraints to this one. So you need to have that information. So I want to copy that. Make sure the number of constraints is equal. It's not. So maybe I should connect it right here. And connect it right here. Okay. Yeah, which should make the number of points and primitive equal. That's pretty important. Okay, now let's copy the goal rest lengths. Seems like a too much setup, but this is really important. And the target that I'm looking for is the base, stretch, and the bend. Bend, I'm not sure, but anyway, I might need it. And for the attractor, I don't really need it, so or anyway, maybe attractor as well. Okay, so let's get all those rest lengths goal from the second input. At prim num. Okay. Okay, let's check. Looking at the primitive attribute. So you have the rest length, you have the goal rest length, which is close to 0. So these are the angle, I guess. If I look at the stretch, so the goal rest length and the rest length, there should be some differences. Are there? Yeah, the goal should be smaller. The rest length is bigger based on the mountain initial shape. Okay, so looks correct. All right. So now that I have enough information, it's connected to the output for the constraints. And this is for the spring, and the spring doesn't really change much because the spring point didn't really move as an initial position, so that's fine. Okay. Now if you just do the simulations at this point, you're gonna have a problem because you have this invalid edge length here. So that's going to be a problem when you in the end of the simulations, which doesn't really look like the pattern we're looking for. But at least it does create the correct inflate direction. So if you look from the top, yeah, it does seem to have an inflate on the top direction, but the edge, obviously the edge length is not correct. So what you need to do now is to fix the edge length, make the edge length, the target edge length of each edge, or rest length of each edge, go back to the original, which in this case is goal rest length inside of Vellum. Now I don't think you can use Vellum constraint property for that, because that's a custom attribute, and I don't think you can access the custom attribute with this. So I'm going to use a subsolver with the constraint geometry option to do that. I'm going to use a primitive wrangle for the constraint, and make the stretch length to the goal. So I am thinking I should probably shorten the edge after I have moved this spring close enough. So after I have make the spring length to 0, I would like to make the edge of the original source to the goal, back to the original. So you have goal rest length, and you have the current rest length. What you want to do is to change this to this one over time. So you can use fit frame, let's say go from 50 to 100 from the rest length original, which is this initial state, to the goal rest length, and apply only for the stretch. You could also do that for the bending, but keeping the bending as the initial state might keep the keeping the rest length for the bending as an initial state might keep this inflation state, so maybe I don't really need to change that, but I could probably only change this stretch. Anything else? Maybe just that is fine. Yep. So let's see. So from 1 to 50, the spring length is gonna be set to 0, and 50 to 100, this invalid edge length is gonna be fixed. See what happens. So 1 to 50 and 50 to 100, the edge length is gonna become shorter and shorter. Is it? Does it become shorter? Doesn't seem like so. Maybe I'm doing something wrong here. Okay, let's check. I want to make sure if I have the right value. So stretch, looking at the stretch, and you have the gold rest lengths. You do have the rest lengths, and not sure if it's being shortened. Yeah, I think it is. But the thing is that rest length is not being updated somehow. Rest lengths, primitive stretch. That's more constraints. Seems like it's not being updated. Or let's see why. If I set it to 0, does it do anything? Okay, it is being updated. What about this? Okay, so this is like 100 frames, so the rest length should be equal to the goal rest length, but it's not. So why is that? Fit add frame 50 to 100, goal rest length original. Okay, maybe a small mistake. Rest length. Okay, check one by one. Okay, 0. Okay, so this is wrong. This is not getting this value. Goal rest length. Now why is that? Or is it changing? No? It seems like it's changing right now. Not sure what's happening here. Let's try this again. Rest length original or goal rest length. Let me also make sure that I'm using the right group name. So this is attractor target, this is stretch, this is bend, this is stitch, and what I'm using is rest length for the stretch. Maybe if I have this vellum constraints, or if I have this vellum constraint property together with the solver, that might be a problem. So I'm just going to do the same things here inside a subsolver. So that's for the stitch. So for the stitch, set the rest length is equal to rest rest length original to 0. Yeah. Hopefully this works. Okay, let's check. Reset it. See what happens. Okay, so from 1 to 50 it's working, and from 50 to 100 is it changing the edge lengths? Doesn't really look like so. Does it? Nope. Nope. Doesn't look like it's changing. So what I'm supposed to have is these edge will become equal to the original edge lengths, but right now it doesn't really look like it's changing its lengths. Need to check it here. Get the stretch. See what's happening here. So if the goal length, if the rest length is really high, get the highest rest length. Okay, well, it is equal to goal rest length, so maybe I'm setting. Maybe I'm doing something wrong here. Why am I having these large number of goal rest lengths here? Am I really copying it? The largest value. Let's try to get the stretch. The other possibility is that the order has been changed with this one and this one. That might cause the problem. That could be really possible. Yeah. In that case, I cannot rely on this primitive number here. Yeah, maybe that's the problem. So in those cases, I need to know the actual lengths before connecting this cloth here. So maybe I should make the cloth before, or let's think. Okay, let's go with this. I'm gonna separate this close into two different constraints. One with the distance along edges, which has this stretch, and then another one which is the bend across triangles, which is pretty much the same. You're just separating close constraints to two different constraints. The reason why I'm going to do this is because I want to put this in between these distance and bend. Okay, so in this case, okay, just gotta that's gonna delete this one. In this case, I'm creating the distance-based constraints with the flat plane. Yeah, creating initial wave, smoothing up, and synchronizing position. What was this for? Okay, yeah, this is for the constraint. Yep. Now, the thing that I got here as an arrest length, which is this one, is the original distance here. Okay. Now, that's good, but I also want to know how much it changed after I moved with these attribute wrangle, how much edge length has been changed with this mountain movement. So I could calculate that by just using the measure node using perimeter length for the stretch. Right? So, and I could name the perimeter to something different, or just leave it as perimeter for now, and replace the original rest length to the goal and the perimeter to the rest length. Okay, using some primitive wrangle. So you have original rest lengths, and you have perimeter. Now you want to set the goal rest lengths to the original one, as well as rest lengths original to the current perimeter. Set the rest lengths to perimeter. So you are just swapping the goal and the rest lengths here. Okay. So for the stretch, you now have goal and the rest lengths being swapped. The goal is going to be the flat condition, and this is for the mountain condition. All right. Okay, I guess this is more safer than the last implementation. Let's see what happens now. And why am I having... Okay. This should go to here. This should go to the second output. Okay. Let's see. So from 1 to 50, you are shortening the spring. From 50 to 100, you are shortening the edge lengths, hopefully. Well, still not working, eh? let's see why. So I have goal rest lengths. I have the rest length, so these are, why is not equal? So these should be equal, but it's not for some reasons. So you have the stretch group. So maybe there's something wrong here. This is working fine. This is for the spring. This is for the stretch. And this one is not really working properly somehow. Why is that? If I just replace it with goal rest lengths, will that work? Let's see. Okay, it does seem to work. So maybe some fitness function that I have wrote is something wrong. Yep. Let's see. So maybe this one is causing the problem. Rest length original. Or fitness function. Wait a minute. Wait. So I have stretch. And I have rest lengths. I have rest lengths original. I have goal rest lengths. Yep. And right now I'm just copying the goal rest lengths to the rest length, so that's fine, but what I want to do is to use the fit function to remap the frame which is in between 50 to 100 to the rest lengths to the goal, but in this case it's not really remapping correctly, is it? Nope. Nope, it's just using rest length, so maybe this one, this here, this fit function is something wrong. Is it because I need to use float? Is that the reason? Let's see. Stretch. Okay, still wrong, still not correct. Interesting. Interesting. What if I just use frame? What kind of value do I get? Oh, wait, fame. Ah, damn. Just stupid spell mistake here. Okay, this should do the job. Yeah, it's changed. Yep. I was writing fame here, but it should be frame. Alright. Stupid mistake. Okay, now this should fix. Now, so from 50 frame to 100, I should be seeing the edge being shortened gradually. back to the original condition, like that, and somehow you are seeing just a bit better result than the previous one, the initial simulation. At least you are seeing these mountain shape or the inflation on the top direction on each stitching places. But you still have a lot of the pattern itself is not so clean yet, so let's try to fix those as well. Well, one thing you could coordinate is the strength of the bending. The bending stiffness is pretty important here in order to have the nice mountain shape, as well as having the nice bending angle constraints is also important. Right now I haven't changed the bend constraints here, so what if I also make the bend rest lengths go back to the goal? Let's see what happens. In those cases, I also need to make the goal rest lengths for the bending somewhere after here. The goal rest length is simple. You just need to set 0 if you are using the flat plane. So, which you might need to tweak a little bit if you're using some other surface. But for now, for the bend, the goal is equal to 0. So and also the attractor might be too big, too strong, so let's make it 0.01 or or maybe attractor was too weak after all. Okay, it's moving a bit too much. Let's see what happens. Gradually it's changing the lengths here. Yeah, I think it's moving a little bit too much. Can't really see what's happening here, so let's make the attractor back to 0.1, and also let's have some space between the changing the spring, which is going from 1 to 50. So let's have some gap between the spring force and the stretch force change. So let's go from 100 to 150. Have 50 frames of gap. See if you get more slower result. And I also might need to change some density for the surface to have a slower result. Make it a bit heavier so that it will simulate a bit slowly. Okay. And well, even if I set the goal rest length for 0 to 0 for the bend, doesn't really change thing, did it? Let's check if it's changing. Okay, so yeah, the bend rest length becomes 0, so that's fine. It's not really it's moving a bit too much, so let's change this distance here, which creates the the mass for the surface, I think. Right here. Maybe this mass is a bit too small, so I'm going to set the density to 1. And also try to change the mountain shape a little bit. Maybe this might be a bit tall, so having a little bit of more gradient. Let's see what happens. Now after this is more of a tweaking the parameters at this point. The system itself is pretty much done, but that parameter tweaking is pretty much important here. And I kind of noticed these wobbling happening in some places. Maybe I want to fix that as well. Okay. Okay, let's see what's happening here. Why it's being having so much wobble here. Probably I should make some space in between the spring. Let's make it 0.1 in terms of the scale. And turning off. Okay, I should also disable compression stiffness, I think. So that I could have a constant stretch force. Okay. Now let me go back to the original sample and see what I did. Try what was the difference. Because the original example that I tried was not having this wobble effect, so maybe I'm doing something wrong somewhere. Oof, yeah, it's having too much wobble here, so maybe something must be wrong here. Let's see why. Okay, so looking back at the original example that I made, having pretty much the same setup, I think, but it's more stable. So something must be different. I'm gonna check what's the difference. So obviously this is creating much better results than the one that I'm making right now, so gotta check what's the difference. Okay, let's check. So it's creating a spring in different ways. I'm using a stitch node, stitch constraints here. Oh, with some smaller stiffness. Maybe this is the one. Maybe. So let's try with this one first. Making the stiffness to smaller value. Okay. Anything else? See if I see some differences here. Yeah, these I do notice this kind of wobbling effect here, which was not shown here, so maybe there are some other differences. Looking at the distance where I'm creating the stretch. So the density is equal to 1, the edge length scale is 0.25. So let's make that back to 0.25. Right. Wait, that was tractor force. I need to do that here. Okay. What else? Well, this one has compression stiffness, so it didn't really matter if I have compression or not. Okay. And I have these mountain shape as a guide, setting a goal, have it bend. So I was trying with 100, which is same as mine. Set it right here, 100, yep. Set the output group to bend, it's also the same. Promotion method, doesn't matter. I'm having the spring on the last, but should be fine. Yeah, I'm not changing any mass or thickness here. So looks pretty much the same. Okay, going inside the solver. Let's also check this one. So I have the spring, which is pretty close to what I'm doing here. And I have stretch. So I don't have a bend constraints here. So 1 to 60, I'm changing the spring. 90 to 200, I'm changing the length. Okay. Well, the frame number is different, but pretty much the same. Right. skip the stretch. Let's make it to the second primitive. I don't think that makes any change, but just in case. Okay, let's see what happens. I'm also want to make sure there's no ground. Yeah, no ground, no gravity, no external forces. Nope. Okay. Now what's happening here? Has to do something with the constraints. Now everything looks pretty similar to the original, the sample, but why am I having the different result here? Okay, this is kind of a debug. Anyone have any image what's going on here? Maybe the shape of the mountain might be the cause of the problem. Okay, let me check each forces again. So okay, let me also check the attractive force for this one, which was created here with like a force of 0.3. Okay, pretty similar. Okay, let's check. So first, so I have disable external, disable self. These are, wait, okay, so those are for the, if it's equal to 0, that's for the attractor target, should be. Wait, source, wait a minute, yeah, that's fine. So, and the attractor target should be equal to 1, so that's fine. What about the mass? The mass, if it's equal to 1, it's 0. If it's equal to 0, it's equal to these values here. And I want to check if the unit is similar. Now, in order to get the final result here, it took like more than 2 or 3 days. So maybe there are some things that I'm missing, forgot. So the mass is a bit bigger somehow. But should be coming from this density value here. Which I don't know if I need to change this one, but I don't think that's the problem here. Yeah, let's keep it to 1. Anything else? VV. Let's check the primitive for the constraints. Now the constraints. Compression stiffness, goal rest length, perimeter, rest length original, stiffness, distance. Yep. Not. For this one. Let's also check the P scale, which is used as a thickness. 0.024. Oh. For this one, 0.00. It's pretty small, but that is based on the mesh resolutions. So I'm not sure if that's the reason. This already have the P scale 0.024. This one also has 0.024. Okay, this is making the P scale really small here. Oops. This might be the reason. Okay, this here. So don't change it. Yeah. So how's this? P scale might be the reason, the thickness might be the reason why I'm having the wobbling effect. Okay. Looks better. Now. Okay, having much better result. Yeah. Okay. Looks better. All right then. So the overall setup is pretty much done. What I just need to do now is to find the best parameter to make the pattern look like the one that I'm looking for, like this one. Now I still need some obviously I still need some setup being done in order to make it close to the original for sure. So gotta think what will be the parameter for that. Well, first thing first, there are several parameters you can control in order to affect the outlook. One is the attractor. The attractor probably is too much attractor might cause the pattern to align in not a good condition. So maybe someone in the comment also noticed that. Balats. What if you were to pin the borders and let the interior points simulate? Yeah, maybe that might be a good idea. Just use the attractor for the border points and keep the interior of the points free. So let's try that first, which I haven't tried before. So Where did I? Okay, so this is where I'm creating the glue. So I could kind of separate the strength or stiffness of this attractor based on the position of the points, whether it's inside a mesh or at the border points, by creating a border group. Use include by edges. Wait, I should actually do that here. Unshared edges for the points. Okay, so did it create it? Oops. Okay, why it's not working here? It's not really highlighting, is it? Why it's not? Let's see if I'm getting the border group. Okay, yeah, seems like I'm getting it. Gotta check with the color node. Border points red. Okay, green. Wait, okay, I'm getting these color as green as well. Interesting. So this is being connected with the spring, so maybe that's why. So maybe I should use the border previously somewhere right here where I created the base. Okay. Okay, and I'm gonna make sure it's still alive after that. Okay, it is. Now, even for these, yep, okay. So, for those glue attractor, I could control the stiffness based on whether it's in the border or not. So if m point group border pt num is equal to 1, I could make the stiffness multiply by 1, meaning doesn't change, but if it's inside, if it's not on the border, maybe I could make it 0. See what happens. So let's see. So currently the attractor is only working on the border and not on the interiors. In those cases, maybe I could make the strength of stiffness of the border the attractor a bit bigger. Okay, so till 150. So compared to the previous condition, maybe I'm getting better. Not sure. Let's make the stiffness a bit bigger then. like 1. Now in this case, this might be too strong. Having too much space inside. So that might not be really good. Yeah. So 0.1 might be a good value here. Now, what I could further try is the bending stiffness, or something like this one, or the initial mountain shape like this one. Let's see what would each difference will do. If I change the stiffness, the bending stiffness to 10,000, let's see what happens. If I could see any obvious differences. Maybe I want to make the stiffness of the springs to be a bit bigger, a bit larger, because I see a bit separation between the pattern. And I also noticed that maybe the bending stiffness is a bit too high. Okay, so make this back to 100. Make the spring force to higher value. So let me look at the comments. So this algorithm could also be used to form a text or any other curves pattern. Yep, totally yes. Why are you using remeshed grid instead of grid with subdivide? One of the reasons is because I want to be able to use more randomized curve, not just a curve on the grid, but more unique curve, which doesn't always align on top of the grid. Okay, obviously the strands was a bit too big. What else I could try? Well, the wave, I could try making the height really high, like this. Making the blur iterations to like 20. Yep, and actually I also want to smooth it out somewhere around here. So how would I do that? Maybe I could use smooth and make those weight equal to 0 positioned where I have set somewhere here. As fixed group. Well, didn't really change, so doesn't matter. Maybe when I create an initial wave, based on the distance for this point, for this each point on the mesh to the constraint point, I could probably calculate so I have these springs somewhere. Yeah, I could use this one as a guide, connect it here, looking for a closest point. Calculate the distance between the current and the spring point. And the length is somewhat between 0 to square root 2 because it's diagonal curve of the length of grid of 1 equal to 1. So I could create a something like that. Then use the fit 0, 1. If it's close to the point, I could say 0. So this is just clumping the value. Then I could multiply it to the height, which will smoothen out the shape here, but have more pointy mountain. So if you don't want the pointy mountain, then you might want to use the power function to, is it, or 0.5? Nope. Guess 2 is fine. Then having blur. In this case, you need more height. Didn't really change. Okay, so forget about it. Okay, well, I'll try with the height of 10 and blur value equal to 20. See what happens. Okay, I want, and I also want to try with scale going to 0. Okay. Okay, yeah, so it's a lot of tackling with the parameters, so it's pretty hard to find a good parameter value. Let me look back to what I have set initially with the example, which it took a lot of time for me to find out as well. Now this one is having a too much like forces on a curve, but well, in the end become a bit better. Yeah. Okay, well, the setup itself is pretty much like that, but in order to have a better result, I want to copy some of the parameters that I set. So let me make sure I'm doing the similar thing here. Okay. So creating the initial wave. Am I using the similar stuff here? So threshold, though I wasn't using multiply by 2, so let's remove that. Okay, using the similar sine wave here, and didn't really have this multiplication, so let's remove that as well. Seems like I had a power function for the height, so why not have that to make it a bit smoother. All right, does it gonna change? And the actual height value is 5 here, so let's make it 5. Okay, for the attribute blur, I'm using 10, so I'll just follow it, 10. So I'm gonna make sure if I'm getting the similar result here. Yeah, it looks similar. The color is bright. Why it's so bright? Not sure why this is so bright, but similar. Yeah. There's of the shape. Okay. Bend. So 100. Same. Mesh resolutions. 0.2, the same. Distance 1. 10 by 10. Just same. Still have the compression stiffness as well. Density 1. Edge length scale 1. That's same. Attractor force. It's a bit different because this is being applied to every point. 0.3 by 1. Attractor points. Okay, so let's say 3 by 0.1. Same meaning. Right. What else? And the spring force. Spring force is where? This one. So this is 10,000. Okay, 10,000. So it seems like everything is being set as much equal as possible. The parameter should pretty much is the same one, and I should be having the same result, but somehow it's pretty hard to predict the simulations. Small difference will make big difference. I have a question, random question, but is there a scale at which a simulation becomes impossible to find a problem with more having to deconstruct and build? Is there a scale at which a simulation becomes impossible to find a problem? Yeah, I think there is always situations where simulations is impossible to solve the problem. In those cases, it just destroys the mesh. If you don't have enough constraints, that would happen easily. Such as the edge lengths constraints, the distance constraints. Okay. So I want to make sure converting this line and comparing it with the original shape, like this one, converting to the line, and compare the edge lengths between two, see if there's any differences. So the edge lengths, if you follow from the first point the primitive number, it's pretty similar. So I think the goal is pretty much correct. It's really working. It's just that the curvature that I'm getting here, it's not really smooth enough. Right here. So if you look at these, we kind of want to attach these face with these face. It's not really happening. Maybe that's due to the the bending stiffness of the cloth or something else. Not sure what's the constraint that I'm missing, or but at least it does give you a kind of idea that it's close to these pattern. I do see these. Well, previously I wasn't able to have this inflating pattern, which both these stitching will give a upward mountain-like folding, which currently does. But I guess I need more constraints to give a result like these having. But that's much more due to the cloth materiality, I guess. That, not sure what's the best parameter for that. If you guys have any ideas for that, that would be great. Well, I could kind of want to have more inflation here, I guess. Probably. Probably. Not sure. And for the attractors, I think I could make it a bit more smaller. Five and simple. Let's try changing some stiffness. For the bending, like make it 10, see what happens. And there's always going to be some space between the clothes because of the collisions as well, because of those p scale that we have set with the thickness value. So that's, we cannot really avoid that, but we can kind of fake that, so we can kind of fake that by make the cloth thicken using like post-process node. Okay, looks better. This one looks better than the previous one. Okay, close to what we want to have as a final result. Now we could use post-process, Vellum post-process, and using the thickness of the collision as the thickness of the cloth, like that. And we're having something like this one now. Oh, that's coming from the spring, so we need to get rid of the spring here. All right, sure. Nah. Guess I need to get rid of the spring from here. All right. So having the thickness didn't really change much. We still have some spaces between here. I guess that is really due to the collisions and maybe also the bending stiffness somewhere around here. If the bending stiffness is too high, then you have some angles here, which doesn't really create a crease on a cloth, so it doesn't really make these clothes touch together. But if you make the clothes bend stiffness too low, then it's gonna make more wrinkles even on top of these inflated surface, so that the balance is really hard. You could also apply some smoothness here, but that's just a small touch. Well, becoming better, but maybe we could try more. So I guess this bending stiffness is pretty important here. I do want to have a crease, but I still want to have some inflated curve. And in order to have an inflated curve, you do need to have some high bend stiffness. What happens if I make it 1? Pretty hard. Can you make the lowest point heavier to pull the highest points closer? Interesting. Maybe. Oh. Looking at the result, it looks a bit better, isn't it? Let's wait until like 150 frame where you have the final length. Alright, it's getting close to what I really wanted to have as a pattern, isn't it? Okay, yeah. Looks good. It looks good. Good enough for simulation. Now I do notice some unnecessary inflations here and here, but overall looks good. So maybe the tweaking the bend stiffness is pretty important here. Right. Maybe if you want to go more, if you want to control more, maybe you can customly set the bend and stiffness based on the spring positions. But overall, the result that I get here, pretty close. Pretty close. Yes. Okay. Cool. Cool. Yeah. I think this is good enough for simulation. To achieve rest, you could just play around with those parameters to see if you can get more better result. Now, let me gather all the parameters that I might want to control later to test out the shape. And let's try with other types of curves. And if you are still interested, I could try on more random geometry, not just grid, but on 3D surface. Let me know if you're interested. If not, I'll just finish it. I'll just finish the live. It's gonna be late. I'm already doing like 3 hours now. Just most of the time just debugging. Okay, so where was I? What's the parameter I would like to control? So I had remesh. Yeah, so first we could, what's this for? Oh, okay, that's not really important. So we have border stiffness. Maybe you might want to have a parameters to say how much you want to affect the interior points to affect the attractor. So the border always equal to 1, but for the interior points you might want to ignore it or not. If it's equal to 0, you're going to ignore the interior. If it's equal to 1, you're going to use all the points to attract. Okay. default is equal to 0. Okay, now the attractor stiffness, this is important. Let's make it 1 as a base. Make the 0.075 as a default value. Okay. Next, this is the edge distance stiffness, which is same as the closed edge dist stiffness. You might not need to change this value. You can fix it to this value, but yeah, probably you don't really need to change this value, but just in case. Bend, yeah, this is obviously the one you really want to change. You want to control to see the differences on the final result. So bend, let's go from 0 to 100. Right, and this is also the one you want to change. This is the spring stiffness. Now, let's make the default, let's make the multiplication to 1. And set the 10,000 to here. Okay, so it's from, I don't know, maybe the maximum is somewhere around here. Okay, what else? Bend, okay, this is not really necessary. Okay, so this, the initial wave parameter, the initial mountain wave mountain parameter is also important, so let's have that as well. So you have threshold, which is coming from the mesh resolution, so that's fine. So you have height. Init mountain height. Okay, from 0 to, I don't know, 20 maybe. And you have the blur iterations, init mountain height blur. Okay. What else? I guess that's pretty much it. And you also have a frame value you might want to control. When to shorten the spring length and when to make back the edge length to the original. So these frame value. So this is actually an integer, so maybe I should make it as an integer. I should have made it as an integer. Anyway, I can just change it here. So spring start frame it's too long. Spring shorten frame end. Okay, thanks for the comment. Yeah, I'll then try to show it how you could make this work on 3D geometry as well. Okay, another one. This was, what was it? 100 to 150, or maybe I could just say like 70 to 150, make it a bit slower. Back to orig lengths, start frame. Wow, that's too long. To original lengths, start frame. To original length, start frame. To original lengths, end frame. To original frame. Okay. Then set this to integer and set the range 1000. Okay, so that's pretty much it for the parameters, I guess. Huh? Let's look with the matcap. Okay, looks, yeah, it looks pretty like it. Take a screenshot. All right. Okay, so let's remember those parameters so that I can come back to these patterns. All right, so if you want to do this for a 3D geometry, that's where you wanted to use remeshing instead of subdividing the grid. Because this, in order to use the same method for arbitrarily meshes on any meshes, you can't really use grid-based geometry or subdivide stuff. So you always want to be based on the remesh for flexibility. Alright, so instead of using grid, let's say gonna think of a really simple 3D mesh like cylinder or something else like lofted surface. Let's see if there's any. I mean, it's a bit it might be a bit hard to do on shape like pig head, because after all you need to place a curve on top of a surface. I mean the spring edge on the top of the surface. So I mean, if you could think of a good way to place the spring on these mesh, that's fine, but for now it takes a bit of time to think what's the best way to do that. So let's go with a shape which is pretty similar to a grid but on a 3D space, like a cylinder. Cylinder is just wrapping the grid, or some lofted surface using a bunch of edges lofted in different direction. Okay, so let's use like line, length of 10, direction to extraction. Let's create yeah, something like that, and let's create a for each loop. Let's create some simple twisted surface and apply the same pattern on the twisted surface. See how it's gonna work. Triangle to create a bowl. Okay, I'm gonna use the point wrangle, or maybe just a transform node for this case. And you accessing to the detail attribute. Multiply by, I don't know, 0.1 or maybe 1. Okay, and also rotate a little bit based on iterations. Using the center pivot. Okay, maybe it's rotating too much. 15 degrees. Okay, then create a skin between these curve. Okay, just a simple twisted curve. Let's make this a bit higher then. Okay, and also let's divide the point line to have a bunch of grids. So I could use these grid to place those curve patterns, or maybe not. Maybe I don't really need to care about those grid point. Just gonna have a bunch of points to make it smoother. Like 30 by. Oh, I can also make it smoother in upper direction. Making a little bit more twisted. Okay, let's go with this. Maybe a bit too twisted. Okay. So the idea is that one of the easiest idea I could think of is to place 2D curve that I've created here. Since I do need these pattern, these pattern layout like this, even on the 3D mesh, to create a final mesh that I got here. Right, so you do need to have this pattern somehow on a 3D mesh. So the easiest way I could think of is to use a UV to map from 2D to 3D. Okay, so let me show you that way. I guess one of the straightforward way to map it. First, create a UV on for this skinned mesh. Does it have a UV? I don't know, maybe not. Nope. If I use a UV quick shade, does it create a nice UV? Nope, it doesn't. So I guess I need to create it myself. Okay. Maybe UV flatten might give easy way to create the. Okay, this is nice. Maybe not. Yeah, skewed right here. Just want to have these as 0, 1 and 0, 1 from bottom to top. So, okay, I'll just do it here. So first I have curve. I am going to use the resample to have the u value, curve u. Actually, don't change the number of points. Just create the u. Okay. So now for each point I have u value, which is going to be used as the u value for the curve. Where is it? I don't see it. Why am I seeing these attribute? Okay, I was pinning. Okay, so curve 0 to e1 curve u. All right, now for this one, I'm creating a v value here. So I could use a point wrangle to copy v value based on iteration value. First get the iteration. Then convert it into v value by dividing the iterations by the number of iterations. Number of iterations is also in the detail from the second input. Convert it into float. Okay. Now this will give you a v value. Now let's check. So you have v going from 0 to 1, and you also have curve u, which is going from 0 to 1. So combining these two, you'll be able to create a uv. Let's do that here. Since this is an open mesh, it's okay creating point uv. If you are creating a closed mesh, then maybe you should use vertex instead. So set f curve u and f at v 0. All right, so now you got uv. Now after that, you can just map those curve and geometry that you created on 2D to here. Yeah, yes, that. So to do that, you need to have enough resolutions for this geometry to have to accept enough points to have here. And this, since this is more of a square mesh, it's a good idea to make the aspect ratio of this width and height for this thing here. Anyway, for now, let's just ignore that and try to map this geometry to this one. Hey, thank you, Gediminas. Yes, the YouTube subscribers got 40k. Thank you, all of you. It's because of you guys. So, thank you very much. So for this one, I also need to create a UV for this flat plane, but that's pretty easy. You could probably use UV quick shade. Yeah, that will create a 2D UV. So that's enough. So now you can use the point wrangle. And does it create on point. Yeah. So you have UV on a point triangle. So what I'm just gonna do here is to move this surface to this surface based on UV. So gonna use a UV sample. The result that I want to get is the sampling value that I want to use is UV, and using the current UV to sample. Okay, and update the position to here. Okay, now do the same for these spring. So for this spring, this is not a surface, so you need 2 steps. First, get the UV for this point from the original geometry, then use that UV to sample, just like I did here. So for this curve, you're referring to the final UV as well as this one, the original grid with the UV. So first of all, this UV doesn't exist for the curve, so you need to create this one. So vector UV is equal to UV sample, and the result you want to get is from the second input, third input, which is this one. And the sampling value you want to look for is the UV, and you want to use P for to sample. And you do have a point position, so by using this you can get the UV corresponding UV value from the grid based on the curve positions. Then use that UV to sample from the second input. There you go. Now you can map this curve on a surface as well. Alright. Okay. So this is going to be the setup. One of the simplest setup to do it on 3D. I mean, there are tons of ways to do on. You could still use this for a more complex mesh like pig head, but you do need to think about, you do need to probably you do need to create a quad mesh from the pig head to have these kind of pattern. So for that, it's a bit more hardcore. Let's go with the more simplest setup like this one first. Okay, so now I have these. The rest I could probably just replace it with this one to test out. Gonna follow pretty much I did here. Let's create a switch node so that I can switch between 3D and 2D. 2D, 3D connected here. Now 2D spring is being referred to somewhere here. Which am I using it? Nope. I can just ignore this, so it's not a problem. So 2D spring here is not being referred to any other places below, so I guess having just this switch is enough. Let's switch to 3D, see if there's anything I need to change. Right here is fine, here is fine. This is another reason why it's good to have a attractor target besides the gravity, because gravity only falls on one direction, but with the attractor you can control the direction flexibly. And border stiffness, yeah, that's fine. Now this is where I need to change. The wave is only creating onto the upper direction. That's a bit problematic. So let's change this so that it creates a wave on normal direction of the surface. So I need to create a normal, point normal, and change the somewhere around here to change the height based on the normal direction. So something like that. Okay, looks good. Yeah, I think it's fine. It should be doing what it's supposed to do. So this is the front face, this is the back face of the pattern. Okay, so let's say that's okay. This is the constraints, the bending. Yeah, all the other stuff should be okay. Now let's go inside here if I need to change anything. Nope, I don't think so. Okay, so that's pretty much it, I think. Let's see what happens. Hopefully it will work. Play. Let's also delete the points. Okay. Gotta wait until 150 frame to see the final result. Finger crossed. And how about it? Still moving, but the constraint change has been finished, and yeah. A bit stretched out because the aspect ratio is different on 2D and 3D, but pretty much you are having the similar pattern on a 3D surface like this, right? So that's how you could do it. Okay, let's remove the texture. There you go. Looks fine. Well, some problem here, but overall looks pretty good. Yeah, so that's how you could do this, how you could create a pattern on 3D surface. Rather related to grid-based surface in this case. If you want to have more complex geometry, then you gotta need to find a way to place the pattern neatly on those surfaces. And you could probably do that using quad mesh. Yeah. And so moving along normals is more flexible. Yeah, I think so. Rather than using constant direction, using normal is more surface free or space free, constraint free. I kind of want to make this surface aspect ratio close to the original, so let me fix that. So what's the best way? This length should be equal to the one of the edge of this bounding box. Okay, so you need to know that information. So I have 4 edges. One is 19, one is 21. So maybe I could refer from this edge length. Let's name this bound edges. And we can refer to the first edge length for this here. So prim bound edges 0. The name of the attribute is rest length 0. Okay. Now you also want to set these edge lengths on the height direction. Now that's a bit more hard to control because it's being rotated. Kind of a need to use trigonometry to calculate that. It's not just a simple height here. Right. Now, what will be the easiest way to do? Maybe I can just scale this to y direction after I've created this one till the surface. Just look at the current scale on here, then just scale it in y direction so that it will become equal to the second length, in this case 21. So yeah, that's more easy to do, I guess. So in order to get the corresponding edge, let's make some information inside here. Okay, I'm gonna use this pointer angle. If PT norm is equal to 0, which is the starting point of the edge, then make it name start. Alright, now I could just get those start points. Alright, like that, and then connect it with the curve. Polygon by group, okay. Now and calculate the perimeter of this curve. Okay, so this is kind of a bit longer than the original mesh, so you might want to shorten to scale down on y direction, but it's not really simple. You cannot just use the simple ratio to scale down because perimeter is not really related to just the height, but it's also affected by the x and z direction because it's being rotated. So what's the best way? Oops. Oop. First of all, you can use pointer angle. Trying to scale. So first of all, get all the necessary informations. One is the target length, which is the primitive, second input, no, third input, rest length 1. And you also have the length calculated from the second input, source length, it's not that simple because I don't think you can just calculate the scale from here to here. If you are scaling all p, then that's fine, but if you are just scaling y bar, then you cannot just use a scale the ratio as it is. So you only need to you kind of need to get the ratio for the y aspect for this one and this one. Let's see how it's gonna look like. Okay, I guess I'm referring to something wrong. Perimeter, rest lengths. Okay, and I guess I should change this scale and recalculate the perimeter to see if I'm getting the right lengths. Okay, I think yeah, obviously I am not getting the right lengths. What I need to get is this length, but I'm not getting the right length here because the scale is wrong. So in order to get the right scale only for the y direction, that's tricky. But the angle is always the same for these points. I think it should be straightforward. So for this point, from this point, I'll just get PT1 from second input, PT2 convert it into the point position. Wait, this is already a point position. Get the direction. Okay, so from here you could calculate the ratio between x and y, right? And what you kind of need to do is to by just changing the y direction, let me think. So you have a line, doing something like this. And you're scaling in y direction to be able to control the lengths here, the diagonal lengths. So by scaling y, you are, in order to get this edge length, yeah, I need to sketch. So let me take a note. So let's say the horizontal edge length is x, so x multiplied by x plus y multiplied by y, and square root is the diagonal length. All right, then I know the goal for this d. I know what's the length is gonna be for this d. So what I need to know is how much I need to change this y, because x is fixed. So I need to create an equation for this y value. So getting easy, x by x plus y multiplied by y is equal to d by d, and make x by x on the left, on the right hand side, and y is equal to square root of d multiplied by d minus x by x. Okay, so this is the final y value. Okay, that's straightforward. And then if the original y is called y dash or y quote, then the ratio is y divided by y quote. Okay, then I should follow these equations. So so I have this ratio here, and so currently I don't have the, oh, I do have the x thing, so it's fine. So, and I do have the current, the final edge length, which is, what was it? This one, 21. So I didn't really need it to get the direction here. So float d, I mean, this is the target length, and this is the current length, so let's call this c. Okay, and x is equal to 0, the first one, first length. Now then y is square root of d multiplied by d minus x multiplied by x, and that's the final y, and we need to know the current y, so we could get that by getting the bounding box. Get bounding box size. So float current y is equal to size dot y. Now the scale for the y is y divided by cy. Then we can multiply y by c. White. Okay, and the final length is, nope, it's not correct. Okay, I think I'm doing wrong. So it's 21 getting from third input, yeah. Yeah. Let me check the current Y. 14.5 and the target Y. Maybe that was not correct. If it's just one edge, that might have been okay, but this being rotated, so maybe that's the reason. Okay, I see. Right. So this condition must be wrong. Extraction. Oh yeah, right. Because the x is not this value. I realized. But x is kind of a direction of the x component of this curve. So that was totally wrong. Okay. Okay. So I could kind of project this on a face and get the measurement of this, and that will be the x value. Right. 1, 2, and I gotta get the period. Now, why am I still getting the wrong result? Okay, well, and it's on the flat face somehow. The target Y is equal to 0. Okay, that's not correct for sure. And what's the parameter for the x? If it's more than 21, then you are not getting any three-dimensional. Okay, it's already more than 21, so that was the problem. Okay, then forget about all the ratio calculations I was trying. Doesn't really work. Sorry for that. So forget it. Forget it. Maybe yeah, didn't really work. Yep. And then, oh well. Oh well. So that was for the three-dimensional mapping. Well, and one thing I didn't try is trying with other kind of patterns. So let me finish this live with trying out different patterns and finish this. Okay, let's go with the simple one first, like this one. Not sure if the pattern is obvious, but let's see if I get. So you have one pattern. So maybe you can create this as one set and place it on X and Y as a repeated pattern, right? So let's create this similar to what I have here. So showing up the grid as a guide, create new curve polygon. Okay, what did it look like? Okay. Okay, so that should look like that. Where is it? Okay, so I think each curve pattern have different parameters for these scales. So you might want to have these set for each curve. So maybe it's not a good idea to have these as parameters, because this is kind of fixed. So I'm going to delete the channel here. Also delete the channel from here as well. I'm just gonna copy this set for this new pattern. Okay, for each pattern you need to have different offset for X and Y. Yeah, I think this is correct. For Y4 for this one. Now, I guess I want to be able to change the curve pattern easily, so let's create a switch. Like that. Let's change this to 1. Okay. Now let's try with the 2D grid starter and see till the end if the same process is okay. Start simulating. See if I get a similar result. Wait until 150 frame. Okay, doesn't really look similar. It does seems to have some patterns, interesting patterns. But if you compare with the shape here, not sure. Don't really see the especially these square pattern. Where is it? So is it on the back? Maybe. Yeah, maybe you're looking at the back side. Maybe not. Maybe because of the some stiffness value or the bending. I might want to add also the bend stretch length to goal, just in case if I might want to change the bending as well. See if this is gonna change anything. So currently the bend goal is being fixed with the mountain goal, but what if I set it to 0? Is it gonna change anything? Which is this one? Let's see. Well, this itself is already interesting though. But let's see if I can simulate physically similar result. Okay, so the result is pretty much the same, so maybe it's not just the bending. Oh, but wait, I do see some similar stuff here. Yeah, in some places maybe. It's pretty hard to determine what's correct, what's not. If I change the bend stiffness to, let's disable that for now, because it doesn't really seem to change anything. Let's try changing the bend stiffness to 10, see if it's gonna do something different. Interesting. Because the bend stiffness is higher, you see more spaces in between, so maybe that's not the right direction. Because you have more cleats here. Oh well, the pattern itself is still interesting, so let's try other one. Shall we? Ooh, it's pretty pointy. Was it this pointy? Did I change something? Oh. Okay, what else? This one? Yep. Look at the zigzag pattern. Let's copy this again. Create this zigzag pattern. Curve polygon. Right, just this. Now the spacing, yep, so this is correct. Change this to 2. Okay, let's see. Whoa, what's happening here? Interesting. Okay, this is obviously something weird, something wrong happening right here. Okay, well, yeah, all the points should be set to the height, set the height equal to 0, but it seems like if the polygon is connected, there's some issues here. So I need to fix that. Okay. Okay, I probably need to convert this into line. This is because this is just a polygon, a polyline. Okay, now looks fine. Okay, now looks fine. Let's try with this. Maybe the attractor is a bit too weak. But I do see nice pattern here. Yeah. Hopefully I'll get the nice result in the end. Maybe I should increase the attractor for this one. It's a bit hard to see. Okay, increase this to 1.15. Okay. Still moving too much, but somewhere around here looks close to those pattern here. So maybe if the simulation is a bit more slower, that might have been better. So maybe these, by increasing the speed here, might give you a better result. And also increasing the attractor here. Right. Yeah, it doesn't look bad. It's just moving too much. Maybe I should also increase the dumping ratio or something. So that becomes a bit more stable, but overall looks like it looks similar to the final pattern. I mean, these shape here, it's pretty similar to what we see here. Maybe well, I do want to have more gathering, but maybe it's due to attractiveness and some bounciness of this surface, if I could reduce that. Which might be due to the vellum close distance dumping ratio or something. If I increase this a little bit more, that might help. Or also the spring. Oh, not bad. One thing I could tell you that you do need a lot of tweak on the parameters for sure. Well, wow, it's moving really wobbly here. At least these part looks nice. Hopefully if I'm able to reduce this wobbly movement a bit more, that might be good. I guess it's due to the constraints or collisions as well, just causing this wobbly movement. Yeah. Well, anyway, let's say I'm okay with it. Closed band stiffness. I think it was previously 1. Okay, looks a bit better. Wow. It's pretty hard to control these forces. There's so many unexpectedness. Okay, well, anyway, if I show this as a matte cap, I do see similar patterns, something like that. Not so much for in middle, in between shape, but I'm not sure where we are looking at. Backside, maybe not. Okay. Let's try other one and I'll finish it. Let's see this one. Okay, so anyway, I'll just upload the files that I've created today so you can just test out by yourself. And if you have way to improve the result, please let me know so that I could play on it as well. So where did I go? that. Okay. Let's try with these. Let me change the parameter to original setup. So close this. Stiffness, attractor stiffness is a bit smaller. Call stiffness. This stiffness is equal to 1. Bend stiffness is equal to 1 as well. Spring, same. Okay, I think I could just leave these as well. Right. Let's see what happens. Okay, what's gonna happen? So doesn't really look okay. Well, look like this. Or this way. Doesn't really look close enough. Maybe I'm missing something here. If I look at, let me just take out the spring, see how it look like. Where is the spring or stitch? Okay, seems like the stitch is pretty long. So probably this is the right proportion. Looking at the stitch curve. Wait, it's the other direction. So if I use the curve like this, okay, so maybe these part should be equal to these part, but doesn't really look close. Huh. Is that really so? I'm not sure. Or this part, maybe this part, but the shape doesn't really look close. Not sure if this is correct or not. Pretty hard to indicate whether this is close or not. Let me try it with really high bend stiffness and see. I'm gonna get any difference. Maybe increasing a little bit of spring stiffness as well. So it is creating a spring here, which is here, here, and here. So this is pretty much correct, but so probably there should be some stretch in between these columns and these columns. The space between these two columns be smaller, but there aren't any forces with these springs, so maybe the attractor stiffness is a bit too big here. Okay, and maybe I could try increasing dumping ratio. Oh. So yeah, it's pretty hard. Knowing the right parameter for the vellum is pretty hard. There's so many parameters you need to look for, try out for. Well, maybe not enough constraints here. I mean the attractor here, but let's see. Yeah, probably I need more x directional force to make look like this one, and probably it's this direction, isn't it? Looks like so. Pretty hard. Well, let's make this back to the original. If I make the bend stiffness to 0.1, maybe I might going to have too much wrinkles. I missed the beginning, so I'm not sure how you set up the contraction, but I think the order of the contraction of the points pulling the thread in the stitching makes a difference in how the cloth folds, and that's why you might not get the same result. You're probably right, yes. When I saw the video for this kind of stitching process, there is an order, yes. So it makes sense that the order of the stitching make the different result. Okay, bending stiffness 0.1 is not really good. So yeah, one obvious, as you said, I could probably try to check the pattern by creating an order of stitching as well. Maybe I'll finish the live by making a simple setup for that. Okay, so I could either like stitch from starting from this, going on the row direction or column direction, or I could simultaneously stitch for each element, starting with this and this and this, everything at the same time. Maybe that makes more sense. So let's start by stitching these diagonal for every element. Then next go this one, and finally this one. So to do that, just need to create an order for each element. Right here. Let's just name this n, coming from primitive number. And the primitive number is 0, 1, 2. Okay, I think that's fine. Right. For everything else, n is equal to, I'm gonna assume n is equal to 0, so everything will start at the same time. So, or, yeah. And I could go inside here. Wait, I need to pass that information to a spring force. So, okay, I have n here. Things that I need to do is I need to pass that n information to those spring stretch that I have created here. This one. So currently this one doesn't have any. Oh, does it? No, the n is all 0 right now, so need to copy the n value comes from here. Hopefully I'll be able to use attribute transfer for that based on the distance. Source group, stitch, destination group, everything. And what I want to copy is this n. Now let's check. Nope, it's not being copied. Should I say spring? Nope. Then need to set the conditions. Forget about the distance threshold. Does it help? Nope. Still not. Okay, then I'll just do it my way. Gonna find the closest primitive using XYZ distance. Then get n from primitive update n. Only for stitch. Okay, now n has been transferred. Okay. So now I can use that information inside the solver. Use that to change the timing when to move the stitching here. All right, so so this is the start, this is the end. Maybe I could use the n with some offset value like 30. So for every 30 point frame, the other stitch is gonna start moving. And let's make this smaller then. So in the maximum there's three stitch pattern, so you have 0, 30 and this is 60 offset, so let's make it 40. Alright, let's see what happens. Starting with the diagonal. Then the middle. Then the other diagonal. Then changing the length. Well, not sure if I'm seeing the difference, but so from 0 to 40 it is changing the first it is doing the first stitching. From 40 to 70 doing the second stitching, the middle horizontal curve, and finally the final diagonal stitching. So maybe if you set more complex conditions, that might gonna change something. Yeah. Also, I might want to try with the interior attractor turned on. Anyway, I guess there are more things you could try with these. I'll just pause the file as it is, like I'm having right now, and leave it to you all to try it out and see if you could come up with better setup. And if you do, please let me know. Yeah. Somewhat close, somewhat far. Really need to think about what's the best general parameters for all. It's pretty hard, as you can see. Anyway, I myself is kind of satisfied with these. I mean, before this I wasn't even able to create a control the inflation direction, so at least from that point of view it's been improved a lot. But I guess there are more things I could do for this. So anyway, I'll leave it to you, and hopefully you could come up with more elegant solutions. I'll finish this up with the first example that I created, trying to see if I'm still getting the same result. This was 0.75. Yeah. Actually, this pattern is really good. So maybe each pattern has some nice parameter to be used. Maybe not just these, but some other parameters that I didn't really promote it. Yeah. Tons of time needed to explore more. Well, sorry for the struggle, but I hope you find something interesting here, as I did. Okay, I'll finish the live stream here. Thanks for joining. And hope you enjoyed at least a little. I mean, a lot of hours I used it for debugging, so sorry for that. But anyway, hope it's worth it. I mean, at least I see what parameters do what. So yeah. Okay, thank you. Okay, so as always, I'm going to upload the files to a GitHub repository. You could download the file from YouTube description page or Patreon. So feel free to download it and use it for your own purpose. Okay, that's it. Thank you for joining, and I am going to go to sleep. It's 3:30 a.m. in Japan, so gotta sleep. Yeah. Good night, everybody, and hopefully see you sometime next week. All right.